Okay, I'll draw it as a series of diagrams. So you've got a server. In fact, you've got two web servers. One of these is something like, I think it was 32 gigs and 8 cores. And then you had another one which was 16 gigs and 4 cores. In fact, it was 8 gigs and 4 cores. Then you had another couple of other database servers. One of them had a 91 gigabyte database and one of them had a 1.5 gigabyte database. So what I'd recommend you do is you take this machine here and you put it into Azure, and the way it will look is it will be, I would suggest, 3 S3 size machines. Now they will all be connected to a load balancer, and you will have a public URL at this point here, say something like patient.uhs.gov.uk, something, I don't know what it is, but something like that. And then what will happen is, if you've got a patient out on the internet, when they hit the load balancer, they'll be load balanced all the different patients. You know, let's draw lots of them in here. Let me just get rid of that. I'm sure you can work out what I'm trying to do there. All those different patients' requests will be load balanced across these 3 different servers. And then what you can do is you can set up a rule here. Set up a rule, and it might say, for example, this is just an example, you can change the rules, but it might say when you get to 80% utilization across all 3 of these servers, so if the CPUs are right up here, almost full up, you've only got 20% headroom, then you might want to scale up by 1. And what that will do is it will give you another server here. It will automatically bring it into the configuration of the load balancer. It's not until this server is ready to receive traffic that stuff coming in from users out on the internet will be routed to it. Then you can set up another route. Let's just imagine that you set this other rule up to say whenever the average CPU utilization across these 4 servers reaches 20%, then scale down by 1. And so what that's going to do is it's going to get rid of that server that you've just provisioned. Let's delete it, get rid of it. And you're back down to 3 servers now. But of course, you know, if you were at 20% on 4 servers, now that you're on 3 servers, that load is going to be spread across 3 servers. So it might suddenly jump up to, I don't know, let's just say it jumped up to 25% average CPU utilization. But let's imagine that more and more users started logging off the system. Then eventually you're going to get to 20% again. And then the rule is, it's the same rule, this rule here, which says scale down by 1. So what's going to happen in that instance is you're going to scale down by 1 more server. And then as the system gets busy the following morning, you're going to be up around about the 80% mark, up here in the 80% mark. And that means that you will then have a rule which is going to fire up 1 more server. So you'll end up with an extra server. It will be joined into the load balancer, and the load balancer will not start sending traffic to it until that machine is ready to receive the traffic. So you get, you know, all of that happens automatically. Now let's have a look at the pricing for this. So to do that on 3 servers, if you had 3 servers as your base, sort of your baseline, let me get to the pricing page. So if I go to pricing and I go to Azure App Services, that's where the websites are shown. Now I would recommend that you go to not F1, which is free, which is very limited, not D1, which is also very limited, not the basics because you can't load balance those, but the standard service plan, I think, and S3, you can see here, S3 standard, which is 4 cores and 7 gigs, but if you've got 3 of them, of course, you've got 21 gigs and 12 cores, and that's £182 per month approximately. Now that's if you run it 24 hours a day. Okay, you can see the prices of these other ones here, £91 a month or £45 a month, and you might be able to get away with running a lesser machine. What I would suggest is that you start with 3 standards and see how it goes. So those 3 standards. Now, what I said was that's the price. You know, was it 182? Let's have a look again. £182 per month. That's to run it 24 hours a day. But if you think that, you know, most of your patients are going to operate between, let's just say, Monday to Sunday. They're probably going to be all, you know, include weekends, aren't they? But they're going to be from probably 7 in the morning until, let's just say, 2400 till midnight. Meaning the time between 2400 and 0700 the next morning you don't have to pay for. Now if we go back to the pricing, you can see that the price is actually 24.44 pence per hour. So let's work that out. If you're going to go from 24 hours minus the 7 hours that you won't be running overnight equals 17 hours times 0.2444 to give it in pounds. It's going to cost £4.15 a day times 31 days, £128. So instead of it being £182, by not operating at night, you'll get it for £128. Okay, let's go back. And we said there were other servers as well. So let me close some of this down. So that was you had that one server there. Let me just draw around this so you can see what I'm talking about. So this server goes into this whole story here. Hopefully that's explained. Next thing we need to do is this server here. It's a lower spec server. Was it 4 cores and 8 gigs of RAM? So let's go back on the pricing, and you can see here 4 cores and 7. The same server will work again. So let's go back here. So you could have another server there for that. Black brush. So there's the other server there. Same price, same deal. You could reduce the price similarly. And then you've got a couple of database servers here. So these have got databases attached to them. Now, I would suggest that you don't actually run them as database servers because it's quite an expensive way of running stuff. But what you do is you buy a SQL service from Microsoft. So let me just get rid of all of this stuff here. Delete that. So whereas this is what you would normally do. You would normally install a VM, install a VM, put a disk onto it, and put maybe even put 3 disks onto it. You'd probably have your C drive, your E drive, and your F drive. Let's just say that this is data and this is logs. And then what you'd end up paying for is you'd pay for this storage, very cheap, something like 1.5 pence per gigabyte per month, which is pretty cheap. But then you'd also pay for this server, for the running cost of that server. And depending on the performance you need, that can be quite a lot of money. So I would recommend that you don't do that. Let's say don't do that, but let's say what you would want to do is to go back and say that you want to have a SQL service. So the way that works is, let's imagine this is the Azure cloud running in Amsterdam or Dublin. And what Microsoft has got in these data centers is tens of thousands of SQL servers. Let me draw that again. How can I? Let me draw it down here. Imagine these are the servers. And imagine there are tens of thousands of them. And then what we do is we put this interface along the front here, which makes it look that way, as if you're connecting to a single SQL server. You're not. You're connecting actually to thousands of them. So here's your web app. Let's just say it's here. One of those servers we just talked about a few moments ago. That talks to SQL Server, and then Azure does all the management of your databases and replication and clustering and all that kind of stuff at the back end here. It gets 3 copies of your data on 3 separate servers on 3 separate disks, and each of those is on 3 separate domains with three separate fault domains with different power supplies, different network segments, different battery backup units, all that kind of stuff. And then your data would be returned to your web server. Now what Microsoft charges for is this service, which is this facade, plus all the tens of thousands of servers in the background and all the clustering and all the software that deals with the availability and everything here. And this is called Azure SQL DB. Now if we have a look at the pricing for that, let's go back to pricing. That's going to be in data and storage, SQL database. And we want the single database. And you can see that the basic one is £3 a month, but all that gives you is a 2 GB database and 5 database throughput units. But what you can do is, you know, for £9 a month, you can have 10 database throughput units. That'll give you an S0. Now I'd suggest that you start with an S3. I think this might be a good starting point for you. It's 100 database throughput units, so it's 20 times the performance of the basic unit, and it's £92 a month. And you get all of that clustering, all of that availability, all of that fault domain resistance, all of that kind of stuff. You don't have to manage the servers yourself. You don't have to apply service packs and patches and all of that kind of stuff. That's all done automatically for you. If a machine fails, then we will automatically move the data from the disk that's on that machine to a different machine and fire up a new machine. You'll be completely unaware of all of this kind of stuff going on. So it's quite cheap to do that, really, for £92 a month. But even if that proved to be, you know, not enough, then you could move up to the next one. It's quite a big increase in price here, but £284 a month. I think that's more than double that, isn't it? But I think an S3 is probably going to work for you at your current load. Now, when you get tens of thousands of users on the system, you might want to scale up in that case. But then, of course, you know, you'd have to scale up in your own data center, wouldn't you? Anyway, so that would be reasonable. Okay, so that's how that would work. Now let's have a look at how we'd price all of this stuff up together. So I reckon you're going to need, my estimate is that you'd need 3 S3 machines for that first large web server. You'd need a single S3 machine for that smaller web server, and you'd need, can't remember what tier it was in, yeah, an S3 database. An S3 database for your £92 per month. Let's go back here. So this be an S3 database for the database server. Now, the other things that you have to pay for is you pay for the storage that's on these machines here, but I think the storage was only like, they were fairly small amounts, and the storage is 1.5 pence per gigabyte per month. So let's imagine this one is something like probably 50 gigs. This one will be 50. This one will be 50. This one will be, let's just say that's 100 gigs. So that's 250 gigabytes times 1.5 pence per month. Let's do that. 250 times 0.015 per month equals £3.75 a month. So storage is going to cost you around about £3.75 per month. You then pay for any data from these machines that leaves the data center. So as these machines are giving data and it's leaving the data center and going out to your patients back at home and in the surgeries and so on, you pay for that as well. Let's have a look at the price of that. I think it's 5.3 pence per gigabyte, but let's just check to be absolutely sure. So we go to storage here. Sorry, it's not that. It's bandwidth is what the egress of data is called, bandwidth. Networking bandwidth. Here we go. 5 gigabytes to 10 terabytes, 5.31 pence per gigabyte per month. So, I said, let's imagine that you've got, and I came up with this rough calculation, didn't I? I said, imagine you've got 100 users. Each one of those users is looking at, five pages. Each page is 1 megabyte, so that's 5 megabytes. And they do that, 100 users, 5 megabytes for each visit that they have, and they do that for 31 days of the month. So let's multiply those numbers out. Oh, sorry, and then it's times 5.31 pence. So it's going to be 100 users times 5 megabytes times 31 days times 0.0531 pence. It's going to be that says £823. That can't be right, can it? Let me do that again. So 100 users times 5 megabytes times 31 days times 100 users times 5 megabytes times 31 days divided by 0.0531. Right, let's try again. 100 users times 5 megabytes times 31 days equals 15,500 divided by 0.0531 equals 291,902. What am I doing wrong here? Goodness me, my phone's going off now as well. Sorry, let's do this again. So it's 100 users times 5 megabytes times 31 days equals 15,500 megabytes, which is 15.5 gigabytes. Now let's do 15.5 gigabytes times 0.0531 equals 82 pence, 0.82. So it's, so let's put that up here, add it on. So storage, data egress equals 82.5 pence. What are the other things that you have to pay for? Let me just get rid of some of this stuff here. Get rid of this. Sorry, I do want to leave all of that there actually. So you've paid for your storage itself, you've paid for the data egress, you now need to pay for each of these machines, and we know that they are a maximum of £182 per month. So that's machines, VMs, and so £182, 182 times, sorry, cancel that again, 182 times 4, 728, and then we know that this database here is going to cost £92. £92. So that's approximately the amount of money that you would pay per month. So what does all that come to? It comes to £3.75 plus 82.5 pence plus £728 for the websites plus £92 for the database, £824. And that's at this pricing. I think we worked out to be 900 and something, didn't we? But can't remember what the difference was there. I probably made an error in the calculation. But if we go back here, this pricing is the most expensive way of buying it. You know, you as a government customer, I'm not sure that you pay VAT even, and you get discount as well. So you will get prices some amount cheaper than this. I'll allow your commercial business manager to tell you what that is. Okay, but I think what I think. Let me just get rid of all this stuff here. You can always wind it back and have a look at it later. What I think a good thing to do is to start with those 3 VMs that I mentioned earlier. 1, 2, 3. Have another VM. You could even put 2 VMs in there. And remember, they'll all be connected to to a load balancer. The load balancer is free. The load balancer included with the websites is free. Then put the auto rules on here. Remember what I said about the auto scaling? Put them on here as well. And set the rules up so that you don't operate between midnight and 7 in the morning. Set all other times to auto scale so that you could operate on I would suggest a minimum of 2 machines here and 2 machines here. And what advantage that gives you is if ever one of these machines was to fail, you've still got your service running. So it gives you good service levels to the patients that you're dealing with. Right, I'm hoping that is pretty good, broad general description of it all. I'll post the video onto YouTube. I'll send you the link. I will make sure that it's an unlisted video, so nobody will be able to find this video other than those who have the URL, which is whoever you pass it on to. But I won't make it generally findable by anybody. Okay, hope that's useful. Cheers.